about dy over dx is its relationship to gradient. Okay, gradient of a curve, alright, at any point itself. Okay, so from here onwards, we are going to investigate and understand how we can make use of this concept to prove certain features of a function itself. So one of the features of a function is about whether is it increasing or decreasing or not. A very typical increasing function, okay, would maybe be your straight line y equals to x plus 2, for example. Okay? Are you ready to start? Okay? I only have about 15 minutes left. Alright, still need to end your 5 minutes earlier, okay? Because otherwise we'll drag into your next lesson. Don't even know whether your next lesson or not. Okay? Then that means I'm left with 10 minutes. Just to tell you the concept. Okay, not very happy about all the noise level. Okay? I asked if you all have any questions for the homework, just to give clarification, just for you to check your answers before you submit it to me, before I have the time to mark it and return it to you. Okay? If this is not a meaningful process for me to give you and run through the questions with you before you submit, okay, then I don't see the point for me to do that. Right? Why I do this is because it does take me some time to mark your homework and return it to you, okay, in time. I cannot possibly mark and return tomorrow. That's impossible. Okay, I can be frank about it. Right? Because I have many other things that I need to do after I step out of this lesson. It's not just about me marking homework. Okay? So because of the timeliness, I feel the need to address any concerns first. Okay? So that by the time I return to you the homework later on, okay, at least you have those concerns addressed already. It is still not too big. Because by the time I return to you your homework, maybe we are already at chapter 14. Which I think is a bit too late. Okay? So if it's not meaningful, let me know. Okay, I don't want to waste time like that. It is even more frustrating when I mark the homework and then people leave it blank. Okay, when I very clearly, I remember I went through it class already. Or the worst, you don't even bother to ask, you just leave it blank. Then I give you the opportunity to ask, you don't ask. Okay? I don't see the need to scream and shout at all of you because you are set 4 already. But it still makes me unhappy. Okay? So, now, increasing and decreasing function. Okay, a very typical increasing function is a y equals to x plus 2. Okay, but if you want to have a very generic image that you want to have in mind, okay, you can think about it as anything that is going upwards. Okay, so as long as I have an increasing function that is somewhat going upwards, okay, how do we understand about the gradient of all the tangents, okay, that are going to be found on this curve? We know that if I want to draw a tangent, okay, at any single point itself, it is always going to be upward sloping. Okay, so what this means is that as long as it is an increasing function, your gradient will always be upward sloping, or your lines of the tangent will always be upward sloping. In other words, your dy over dx must be positive. Okay, so increasing function means that if your dy over dx is positive, okay, then the function fx is increasing. Okay? Then when it comes to decreasing function, an example could maybe be y equals to negative x plus 7. Okay, decreasing meaning to say that it just goes down. Okay, a general image that you can have in mind is okay, that really just goes downwards. Okay? And if I were to find out what is that tangent, okay, along any point itself, so this is number 1. Okay, for any tangent that we have drawn, it won't always be downwards sloping. Okay, in other words, for our decreasing function, we know that if dy over dx is less than 0, then fx is decreasing. Okay? But our functions in general, they are not, it may not actually be a case of always increasing and always decreasing. So for example, your y equals to x squared curve. Okay, in our y equals to x squared curve, we see that down here, our tangents that we draw will be downward, okay, going in this manner, whereas our tangents on this side will always be upwards. Okay, so this is a function whereby it is not for all values of x, alright, that it is actually increasing or decreasing. So only on this side, then it is decreasing, this side is increasing. So to write it in mathematical terms, we say that when x is less than 0, because this is where your x is negative, okay, y equals to x squared is decreasing. And when x is more than 0, y equals x squared is increasing. Okay? So it can be just for specific values of x, whereby our function is increasing or our function is decreasing. It may not be all the values of x. Right? So this idea of all values of x, all real values of x, this one we touched upon it when we first got introduced to A Maths last year. Okay, set 1 and set 2. Chapter 1 and chapter 2, sorry. Okay, let's start off with something very simple first. So looking at exercise 13.2, question 1b, we are given that for y equals to x squared plus 2x, okay, we want to find an expression for dy over dx. Okay, that's the first part of the question. Second part of the question asks to explain why is y an increasing function. Alright, so looking at y equals to x squared plus 2x, our dy over dx will be 2x plus 2. Right? And in order for us to explain that it is an increasing function, we know that our dy over dx must be more than 0. Okay? But how am I supposed to show that 2x plus 2 is more than 0? Please don't sub in any values, okay? Because there are a lot of values that you can sub in. You cannot just happily choose one value that you like and then you put it in. Okay? So in order to explain why y is an increasing function, by showing that this is more than 0, we make use of the inequality over here, because questions say that this function is defined for x more than 0. So when x is more than 0, okay, that means that 2x itself, that means 2 times x, must also be more than 0. Okay, we are trying to work towards our 2x plus 2. So 2x plus 2 will be more than 2. Okay, because I plus 2 on both sides. Alright, and 2 is more than 0. Okay, so this is how I show that 2x plus 2 is actually more than 0. Right? And therefore, I can conclude that y is an increasing function. So, since dy over dx more than 0, then y is an increasing function. Let's try one more before we call it a day. In this question, we are given fx equals to x power 6 minus 5x. Keeping in mind that this function is defined for x less than 0. Okay, I want to find the derivative f prime x. So we differentiate to get 6x to the power of 5 minus 5. And then our goal is to show that fx is a decreasing function. And in order to do that, our derivative must be less than 0. So to do this, okay, we know that when x is less than 0, okay, I always target the x first. So x to the power of 5, alright, we know that it is less than 0. But why? Okay? You cannot just happily because you have this objective you want to fulfill and then you just anyhow do. Okay? You must try to think logically. If x is less than 0, let's say negative 2. Okay? Negative 2 to the power of 5, we know that, okay, when our power is actually an odd number and our base here is negative, negative times negative give us positive, times another negative give us negative. By that pattern, okay. Sorry, not enough space. Okay, so negative, negative, positive. Then positive and negative give us negative. And negative again is positive. Another negative gives us negative. So overall, this number is negative. Therefore, we can say that x less than 0, x power 5, 5 being an odd number, will have to be less than 0 as well. Okay? So, please be clear about this. Right? Don't just anyhow jump to conclusions. Okay? So, since x power 5 less than 0, then we do our multiplication. Okay, 6 times 0 is 0. Then we minus 5 on both sides. And we see that 6x to the power 5 minus 5 is less than 0. Okay? So with that same conclusion, since dy f prime x is less than 0, then fx is a decreasing function. rather intuitive because you know that increasing must go upwards, your tangents must always be going upwards. Therefore, the gradient must always be positive. Whereas for decreasing, it is about going downwards. Since the idea is decreasing, your tangents will all be going downwards. Gradient will then naturally be negative. Okay? So, therefore, draw these two conclusions over here. Okay? It is rather intuitive just by looking at the diagram and understanding the words itself. Okay? Any questions? Okay, let's take a look at this question. We are given this curve y equals to x cubed plus 3x. First of all, we want to find dy over dx. Okay, what would the dy over dx actually be? Yue Yi, what do you think? 3x squared plus 3 great. Okay. The key challenge is to look at part 2. The question wants us to show. Okay, so we need to provide the evidence to show that y increases as x increases. So this, in other words, is talking about when the x value increases from left to right, we want our y values to actually be progressively increasing as well. So that means we're looking at the increasing function, unlike the decreasing function, whereby x increases, our y decreases. Okay, so what we want to show is to actually show that it is an increasing function. Okay, so that means that we need our dy over dx to actually be positive. But the problem here is, how will we know that it is positive? Okay, because this is a bit different from what we did yesterday. Yesterday we had a certain inequality that's given to us, okay, for us to work with. Whereas for this one over here, there's no inequality. Okay, but we can look at the expression closely, okay, to understand what it is. So we know that for all real values of x, so long as we square them, okay, whenever you square a number, okay, what kind of observation you can get from the number itself? It will always be what? Positive, right? Okay, so for all real values of x, okay, that means for any values that you know about x squared will have to be positive. In fact, not just positive, it can also be equals to 0. Okay? So let's be very careful about this inequality. Not just positive, but also have the equal sign at the bottom. Okay? Then we manipulate this inequality. So this is how we generate our first inequality in order to work towards having our 3x squared plus 3 be positive. So 3x squared will mean that we times 3, 0 times 3 will actually be 0. Then after that we plus 3. Okay, so that means 3x squared plus 3 is more than or equals to 3. And 3 is definitely more than 0. Therefore, we have shown that dy over dx is actually positive. So, since dy over dx is more than 0, then y increases as x increases for all real values of x. Okay. The questions that I've introduced to you are questions where we want to show that dy over dx is positive. Then we can prove that it is going to be an increasing function or a decreasing function. Okay. Now looking at try 3, the question gave us an equation of a curve as well. But instead of proving something, they tell you that y is increasing and they want you to find the range of values of x. Okay? So it is just like the idea yesterday where I told you, okay, there could be functions like y equals to x squared. Okay? Whereby y equals to x squared is not always increasing, neither is it always decreasing. There are parts of it that is increasing, parts of it that is decreasing. So the objective of this question is to determine what is the range of values of x, such that you observe the increasing part. You understand? So for the increasing part, we know that dy over dx must be more than 0. Okay? So we first find out what is our dy over dx. And we find that it is 6x squared plus 6x minus 12. And then as mentioned earlier, for y to be increasing, our dy over dx must be more than 0. In other words, 6x squared plus 6x minus 12 must be more than 0. Okay? So we are trying to find out the range of values of x. Okay, I hope this kind of ring a bell. Not sure if it is a good bell or an alarm bell. Okay, so how we go about solving this is a quadratic inequality solving that we did in chapter 1 and 2. Okay, in maths last year. Right, so how we solve this? We first see that there is common factor. So let's try to reduce it first. Okay, divide by 6 throughout. We get x squared plus x minus 2. I know that many of you very conveniently like to press calculator to factorize this. Okay? Unfortunately or fortunately, okay, during your WA, I spot a lot of you, okay, factorize and yet it is inconsistent. Okay? You tell me that the answer is plus 2x minus 1. Okay? And you don't have this step. Alright, you tell me 6x squared plus 6x minus 12 factorize to become x plus 2x minus 1. They are not equivalent. Okay, you cannot use your calculator to do your factorization. Alright, while I did not penalize you for your WA, okay, I don't want you to actually learn your factorization by using calculator. Okay, so please do your cross method. So 6x squared plus 6x minus 12, technically you should reduce it first. Okay, then this and this, yes, this one expand back to this one factorize to this. Okay, so please ensure that your steps are consistent. Okay, so we get x plus 2x minus 1 more than 0. So that's the first step of solving quadratic inequality. Factorize first, then we look at our number line. Okay, our x squared coefficient is positive, that's why we have a smiley face. Okay. Then after that, our x-intercept will be negative 2 and 1. Since we're looking at more than 0, that means it is above my x-axis. So it is this part over here. In fact, we're looking at this range. So therefore, it is x less than negative 2 or x more than 1. Okay? So I hope you try to recall this, because we're going to use that quite a bit. Okay? Any questions? Right, so that will be the answer, okay, for the range of values of x such that y is increasing. We have these two ranges. Showing question. they gave us an inequality where x is less than 1. So we need to first differentiate our y function. So our dy over dx, what would it be, Ziyue? What is our dy over dx? Sorry, minus 1. Bracket. X minus 1. Then negative. Sorry, I can't hear you at all. Negative 2. Okay, to the power negative 2. Anything else? No more? Okay, so this is a differentiation of your y. Okay, we should be getting this. In fact, you can drop the 1, so it just be negative. Okay, we want to show that this will result in a decreasing function when x is less than 1. Okay, so how do we actually go about showing that this will be less than 0? Let's maybe rephrase this into this form. Okay, which will help us better. So we need to show that this is going to be negative. Hang on, let me just check out. Okay, so we want to show that this is going to be negative when x is less than 1. So when x is less than 1, okay, our x minus 1 working inside the bracket first will be such that it is 1 minus 1. Okay, that is equals to 0. Right? Okay, then after that our x minus 1 squared. Okay, since it's less than 0, when you square it will still be positive. Okay, in this case there's no way for it to be more than or equals to 0. Okay, reason is because x minus 1 itself is strictly less than 0. It is not possible for it to be 0 at all. Therefore, this has to be a strictly positive inequality. Okay, down here cannot be equal 0, so surely down here cannot be equal to 0 also. Okay, so then negative 1 over x minus 1 squared. So we look at this fraction itself. If the denominator is going to be positive, down here is a negative 1. Negative number divided by a positive number, surely it has to result in a negative number. Okay, so we have to think about it in that manner. Okay, it's not about having negative 1 divided by a positive number. Okay, so we will do more about this later on as the fraction gets more complicated. Okay, so therefore, since dy over dx is less than 0 for x less than 1, then y is decreasing. We do the same way. We don't need to go and differentiate because we have already done so over here. So we'll just work with x more than 1. Okay, same thing, we look at x minus 1 first. So x minus 1 is more than 0. Okay, even if it is positive, when we square it, it will be positive as well. Impossible for it to be equals to 0, therefore it is a strict inequality. Naturally, okay, this one should follow. So the negative of the fraction here will actually be less than 0. So conclusion remains the same. Just that it is for x more than 1. forget, just want to ask, is this going to be your seating arrangement for the rest of the year, or are you shifting back? This will be it. Okay, can. You all mind if I change your seating arrangement just for maths? Your thing is okay? Okay, I want to have a different seating arrangement for maths. Okay, tables and chairs can still remain. Just the seating itself, I want to rethink about it. Okay? Okay, let's look at exercise 13.2, question 7. This is the one where I want us to really pay attention to. Okay, so we're given the y function. We want to find y over dx. And hence find the range of values. X for which part I, y is increasing. Part 2, y is decreasing. Okay, so again we want to find the range of values. Okay, given the information that y is already increasing, given that y is already decreasing. Okay, so the first thing that we surely should know how to do at this juncture is to do the dy over dx. Okay, could I give you maybe about 2 minutes, okay, to go and do your dy over dx, right? Such that eventually I want you to be able to show that your dy over dx is equals to 3x minus 7 over 2x minus 1 to the power of 3 over 2. Okay, I give you about 2 minutes to work on that. Okay, do your quotient rule, try to get this. about product rule is in terms of making it into single fraction. Okay, maybe let me just complete this quotient rule one first. So this will be how you do it if you do quotient rule. Give me a minute, let me try the product rule. Okay, maybe let me run through your quotient rule one first. Okay, so this question itself, right, you cannot run away with making it into the single fraction. Okay, you have to make it into a single fraction up to this extent. Okay, I will be explained in a moment when we continue trying to solve the problem. Okay, so when it comes to using a quotient rule, right, always see that this one actually goes down to your multi-layer fraction first. Make them same denominator. Recall that every time you make same denominator, the other side must multiply with this denominator here. Okay, that's why we have this extra square root 2x minus 1. Okay, then our denominators now can combine together to form this one. Okay, our 2x minus 1 is actually a power of half. This one is power of 1. Half plus 1 gives us 3 over 2, which explains why I eventually get this. Okay, then after that, the numerator, I simplify it, I will get the answer that I want. Okay, as I walked around, I noticed some of you like to do product rule. I think that is also evident in your WA itself. Okay, some of you like to do product rule, whereby actually in your WA you don't even need your product rule. Okay, but that's for another case. So dy over dx in this case, we keep the left side, differentiate the right. We have this. I want to point out that this brackets over here is essential, because if you don't have the brackets, what it will look like is 3x plus 4 minus half times 2x minus 1 to the power, then after that times 2. Which means a totally different thing from when we have the brackets, because these are connected by multiplication already. Okay, so do be aware when are the brackets actually essential and when it's not. Okay, it might change to a different story. Okay, Then after that, over here. The problem when you use product rule is that you have no sense of awareness of fraction. Okay, likely you will not be able to continue and you need to answer maybe in this form. Okay, and then you don't get to actually have your single fraction. Right? So we need to still have that sense of fraction itself. Whenever there's a power of negative, we bring it down to the denominator. Likewise, this one, bring it down. Okay? Then the next challenge is, how do I put this and this, okay, this fraction and this fraction, to share the common denominator? We see that the 3 over 2 is a bigger power. Okay? So our denominator, our common denominator should actually be the one that is of the bigger power. So that means this half over here, I need to multiply with something in order to get a 3 over 2. So we understand what does this actually try to mean. So let me try to arrow it up here. 2x minus 1 to the power of 3 over 2. It means that we have 2x minus 1 to the power of half. And we want to multiply by something which is also 2x minus 1. Just that the power itself, half and something, they must add together, okay, in order to give me my 3 over 2. Therefore, the power here must actually be 1. Which explains why eventually my 3, I multiply with a 2x minus 1 in the numerator. Okay? Then after that, I expand the numerator and simplify, and I'll get this one already. Okay? Questions? Okay, it is algebraically challenging. Okay, if you need the time to go and digest, please take it back home to digest. Okay, don't have indigestion. Right? It's not going to be healthy. Okay. Questions? Okay, we continue. Okay, because we have not yet even reached the aim of the question. Okay, whereby y is increasing. What time did my lesson start? 40. Okay. So let's look at part I, okay, where we want to show that y is increasing. Okay. Can I erase the quotient rule part already? I just leave this answer here. Okay. Now, question wants us to find the range of values of x such that y is increasing. That means that my dy over dx needs to be positive. In other words, my 3x minus 7 over 2x minus 1 to the power of 3 over 2 needs to be positive. Okay? Now this is the part whereby we need to be conceptually sound. Okay? When it comes to an equation, we need to say this one is equal. I can happily say that 3x minus 7 equals 0. Okay? Because I can so-called multiply this to the right hand side and then I have 3x minus 7 equals to 0. But logically speaking, okay, why is it that only the numerator can be equals to 0? Because if we look at this as a fraction, in order for this to be equals to 0, only my numerator has to be equals to 0. If my denominator were to be equals to 0, I cannot divide by 0. Correct? So that satisfies our logical understanding. Okay? So therefore, for equation, it makes sense. Okay? And it's somewhat consistent with the idea of multiplying to the right hand side. But then, when it comes to an inequality, okay, I cannot happily multiply this to the right hand side because our inequality rules state that, okay, I can only multiply or divide a number, okay, because if I multiply a negative number, my inequality flip. Remember that? Okay, we learned that in Set 2. Okay, when I multiply a negative number, my inequality has to flip. So for example, okay, if I say negative x over 2 is more than 0, I need to multiply over to the other side. So maybe not 0, let's work with just 3. Okay? So 3, I multiply by negative 2, my inequality has to flip. This is what we learned in Set 2. Okay? But the problem here is that, unlike this question, I know that 2 is going to be negative. Okay, I know an actual value to it. Whereas over here, right, with the x, I don't know the actual value. Okay, so I do not know whether is this thing at the bottom positive or negative. Okay, so I cannot happily take this one, multiply to the other side. You understand what I'm saying? Okay, then the problem is then how to solve. Okay, so we go back to our logical understanding that we learned in set 1 in fact. Okay, set 1 we learned that positive divided by positive will give me a positive, right? Okay, so that is case number 1 because down here is positive. Alright, another option we can take is negative and negative give me positive. Agree? So I'm looking at 2 cases over here. One case is that 3x minus 7 is positive. The other case is 2x minus 1 to the power of 3 over 2 is positive. The other case is a negative case. That will give rise for me to have this positive in the end. Okay, so let's write down the cases. Okay, okay, for y to be increasing, either 3x minus 7 is positive and the denominator is positive, or numerator is negative and denominator is negative. Okay, so we present 2 cases. So let's continue. We want to find the range of values of x. So the thing is that out of these 2 cases, okay, what is actually logical? Okay, sometimes at this stage we can actually go about eliminating the case already. Okay, let's look at understanding this part here. Okay, having 2x minus 1 to the power of 3 over 2. Okay, over 2 means to take square root, right? Okay, when you take square root itself, it should actually be a positive number, right? Because we take the positive square root. So having to the power of half, it represents positive square root. So technically, this thing here should only be positive, okay? Can never be negative for any values of x. You understand? Having power of half means positive square root. Your value can only be positive. It can never be negative. Okay? So we say that since x minus 1 to the power of 3 over 2 more than 0 for all real values of x. Okay. That means that I can only be looking at case number 1. I eliminated case number 2. So we are only looking at solving this inequality and this inequality. Okay. So we are solving 2 simultaneous inequalities at the same time. This one is your usual linear inequality. I want to find the value of x. So I'll just shift the 7 to the right side. They're all numbers, so plus 7. Then 7 divided by 3. So x is more than 2 and 1/3. Okay, yes actually. Okay, Ashley was asking, okay, because in lower set we learned that whenever we square we should get positive and negative, right? Okay, but that's a different idea from this one. Okay, why is it a different idea? In this case, right, the question already tell you, okay, that they square root for you already. Okay, the question is already given to you the square root. Okay, and the square root that they have given you is the positive square root. They never give you the negative square root at all. Okay, because a power of half, okay, is only referring to a positive square root. That's the definition. Okay, whenever you write 2 to the power of half, okay, it only means square root 2. Okay, only if you put negative 2 to the power of half, then it is negative square root 2. Okay, whereas over here, they are presenting to you the square root 2x minus 1. So that is actually this one, positive value only. You understand? That's the definition now, okay, of how we write our index in our power to be half. Okay, that's why it's not possible for it to be negative. Okay? You can, if you want, you can go and look back at your set 3 maths textbook. Actually, just nice yesterday, some of us teachers were also looking at the definition. Okay, the definition did say that it is actually the positive square root. Okay? So, sorry, I only completed one side. Haven't do the other one. Okay? Now the other one, how to solve. Okay? Whenever we solve inequality, I can only plus, minus, times, or divide. Because those are our 4 operations. There's no such operations as square root. Okay? So, I know square root is a function, okay, a way to actually apply to something, but we usually only plus, minus, times, divide. They are very basic operations. So in this case, how do we then get rid of the 3 over 2? The answer is that we cannot get rid, but we can understand what this is trying to say. Okay? So it's trying to say that this entire thing is more than 0. The entire thing can only be more than 0 if the inside is more than 0. Because if the inside is less than 0, can you even square root? You cannot, right? Okay? Because down here is square root. So therefore, from here, we conclude that 2x minus 1 is more than 0. Okay? And then this one leads us to solve that x is more than half. Okay? Okay, so we have 2 inequalities, x more than 2 and 1/3, x more than half. If you refer to your number line, 2 and 1/3, half, both are more than, the overlap is here. Therefore, the range of values of x is only when x is more than 2 and 1/3. We are not rejecting anything over here. It's just by interpretation of the number line. Therefore, I conclude x is more than 2 and 1/3. It is not a rejection, so please do not write any reject. Okay? Yep, let's go. regarding this? Okay, so I want us to be able to see that the whole reason why when we do our quotient rule to get it into a single fraction is because if I don't have it in a single fraction and I have it written in this kind of manner, there is no way for me to solve the inequality at all. Okay? Because these are all algebraic variables, I cannot say bring one to the other side and then divide your variables away. We cannot do that kind of things when it comes to our inequalities. Okay? So that's why we have to make it into a single fraction and go back to our understanding of plus and plus give us plus, minus minus give us plus, plus minus give us minus. Okay? So those are our key concepts that we learned when we were in Sec 1. Okay? Alright? Then let's finish up part 2, okay? Okay, part 2 we want to do for increasing. Okay, so same thing applies. 3x minus 7 over 2x minus 1 to the power 3 over 2 less than 0. Okay, now just now Jasper was asking me, okay, is it just always take on top positive, bottom positive can already? Okay, if your idea is that way and we apply it to this, I want us to think about it. Okay, if I were to write this, is this logical? Okay, it isn't. Jasper, I want your attention. Okay, if ask you give me homework, give me the same kind of mistake, it isn't logical. This and this step is not logical because, okay, if top is negative and bottom is negative, by right the whole fraction should be positive, right? Okay, very good. So therefore we cannot be having this kind of case. So the cases that we should be looking at, okay, are two different cases. 3x minus 7 is positive and the bottom one is negative. Okay, so top positive, bottom negative, or the other way around. Okay. So these are the two cases. Then, okay, because just like what we did earlier, we know that the square root will have to actually be positive. That's why we totally reject the first case already. Okay, so reject this one. Right, so over here we rejected this one. Then it's about your usual solving. Okay, so 3x minus 7 less than 0, shift the 7 first, then divide by 3. Whereas this thing, same thing applies. If the entire expression is positive, the inside must be positive. Okay? That's why we say 2x minus 1 is more than 0. Then draw number 9. Okay? We have x more than half, x less than 2 and 1/3. The overlap is here. Therefore, conclusion is that x is between half and 2 and 1/3. Okay, so this is the answer. which I clearly can tell that Jovia has already sunk into a different world. Okay, and I definitely see your Instagram page is always constantly updated with a lot of your sleeping. Okay, maybe I could contribute to those photos one day as well. Okay, which I hope not to contribute. Right, so Jovia, you may want to reflect. Okay, by staying awake to reflect, not sleeping and reflect. Okay. Right, we're ending for today. Tomorrow we'll continue. Tomorrow we got, is it our 1 hour 20 minute lesson? Yes, okay. Jovia, be prepared now, 1 hour 20 minutes, stay awake, huh?